I'm Anil Kumar. Welcome to my series on logarithmic functions. Now we have four very important test questions for you. I would like you to pause the video, copy these questions, answer, and then look into my suggestions. Question number 1. Write an equivalent expression for log x squared. Question number 2. Write f of x equals to this as sum or difference and find domain. Question number 3. Show that if a cube minus b cube equals to 3a square b plus 5ab squared, where a is greater than 0, b is greater than 0, then log of a minus b by 2 equals to 1/3 of log a plus 2 log b. Question number 4. Show that if 36a square minus 169ab plus 144b square equals to 0, then log of 6a minus 12b divided by 5 equals to log of square root a plus log of square root b. Let's begin with the very first one. Now, this seems to be a very simple question, but somehow a mistake can happen here. Log of x squared we have to write as an equivalent expression. So we could always write this as 2 times log of x. Now if you write like this, that means you have already committed a mistake. If you notice, when we have log of x squared, what is the domain of this function? Domain here is that x belongs to all real numbers, right? Except for it cannot be 0, right? So x is not equal to 0. So except for that, it belongs to all real numbers. Now in the case of 2 log x, that domain is not really reflected. So what should you do? So first, you should make it absolute value of x, and second, we have to add a condition that x is not equal to 0. Now it becomes the correct answer, right? So without this condition, the equivalent fraction is incorrect. So without this condition, the equivalent expression is incorrect. So I hope you agree with me, right? Now let's look into question number 2. So let's do them on a fresh page. We need to write the function f of x equals to log x squared minus 16 over x cubed as sum or difference and find domain. Normally, how are we going to do it? Simple rules, right? So it will give you, let's first write this in the factored form. So we could say this is x plus 4 times x minus 4 over x cubed, right? And from here, we can write this as log of x plus 4 plus, since it is a product, log of x minus 4 minus log of x cubed. And then we may write this as log of x plus 4 plus log of x minus 4, and applying the power rule, 3 log of x. Well, if you do that, then again there is a mistake, right? So here again there is a mistake. So I'd like you to find the error in the above. Meanwhile, let's try to analyze the domain of this particular function. So take your time to find the error. So as far as the domain is concerned, I prefer to sketch the graph and find out the domain. X cubed is a function which will be kind of like this, right? And the parabola will be let's sketch it like this. Okay, so that becomes the parabola where these zeros are at minus 4 and plus 4. Now the parabola function divided by this Of course, we cannot have 0 as a part of domain, but what can we have as domain? When both the functions are either positive or both are negative, right? So we want all this to be positive, right? So looking at that, if I consider the points beyond 4, both are positive, and in this interval from -4 to 0 also the expression is positive, right? So what are we looking for? We are looking for x plus 4 times x minus 4 over x cubed to be greater than 0. Now this clearly is when x belongs to the interval from -4 to 0 and from 4 to infinity. Correct? Now if you look into this domain, then in the domain -4 to 0, this will be negative and this will also be negative. So you cannot really write this expression in that form. So I hope you're getting the point, right? So that is why I repeated the concept of question number 1 in 2. So what should you do? You have to put them as absolute values. You get the idea, right? So we have to place absolute values on this. Now you get the right answer, and so our answer should be f of x equals to log of x plus 4. No need to write absolute value here since the domain is, this is always positive in the given domain, right? Plus log of absolute value of x minus 4. It won't be wrong if you write absolute value, right? Let me say that also. 3 times log of absolute value of x. It does make sense. And we wanted to know what the domain is. So the domain I've written earlier, which is kind of like this. Perfect. So that is how it should be done. Correct? Now before doing question number 3 and 4, let's take a small break. A fresh walk along the river Humber. Let's enjoy these ducks. After the break, we'll take solution of question number 3 and 4. I hope you enjoyed the break. Now let's continue. Question number 3. Show that if a cube minus b cube equals to 3a square b plus 5ab square, where a is greater than 0, b is greater than 0, then log of a minus b over 2 equals to 1/3 of log a plus 2 log b. Now in this particular question, you should know what is a minus b whole cube equals 2. So let me share the formula with you. A minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. So we will do like completing the cubes this time to solve this particular question. Let's see how. So what are we given here? We are given a cube minus b cube equals to 3a square b plus 5ab square. Now on the left side, these two terms are missing for making it a perfect cube. So what are we going to do? We are going to add these two terms on both the sides, correct? So that is the strategy. So basically we are completing the cubes now. So let me write down here. The step here is complete cubes. Now this is a very critical step to solve such questions. So we have a cube minus b cube. We are adding these two terms, which are minus 3a square b and plus 3ab square, right? So we'll add them on both the sides. We had this term here, we could have taken it to the left also. Purposely I didn't do, since sometimes we may not have exactly the same term. So we are going to add this on right side also. It becomes 3a square b plus 3ab square. Now the left side is a perfect cube. We could write this as a minus b whole cube. And on the right side, as you see, 3a square b cancels out. 5 combined with 3 gives you 8ab square. Perfect. Now we are very close to our result, right? So from here, I think you can see the result. So let's rearrange. We get a minus b whole cube divided by 8. Since we want 2 in the denominator, right? And here we have ab square. Now 8 is 2 cubed, so we could write this as a minus b over 2 whole cube equals to ab square, correct? Now since we need that expression, we have to only take log on both the sides. So taking log on both sides, we get log of a minus b over 2 whole cube equals to log of ab square. Applying the power rule, we get 3 times log of a minus b over 2. And here we can expand this and write this as log of a plus log of b square. Dividing by 3, on the left side, we are left with log of a minus b over 2, which is required. And then here we get 1 over 3 within brackets log of a, and we want 2 log b, which is with power rule 2 log of b. Does make sense, right? So we have shown that this identity is proven. Perfect. Go through these steps. Here is a very critical step of completing the cubes. Now in question number 4, we are going to apply a similar strategy and we'll do completing the squares. Question number 4. Show that if 36a square minus 169ab plus 144b square equals to 0, then log of 6a minus 12b divided by 5 equals to log of square root a plus log of square root b. So what are we given? We are given that 36a square minus 169ab plus 144b square equals to 0. Now to make this a perfect square, which is 6a whole square, right? So we could write this as 6a whole square. The right side for us is 12b whole square, the last term. In the center, what we need is 2 times 6a times 12b, right, to make it a perfect square. Now what do you notice? This number is 12 times 12, 144, but we have 169 here, right? So we do have 144, but 25 even lesser. So we could write this as minus 25ab equals to 0. Does it make sense to you? So what we did was, basically, we wrote 169ab as equal to 144ab plus 25ab, right? Since that was negative, all these are negative terms. So that is what we substituted for 169ab. Now this helped us to make a perfect square right there, right? So now we could write this as 6a minus 12b whole square. And taking this to the right side, I will write this as 25ab, right? So I've rearranged. Do you get the idea? So first three terms, these three terms here are perfect squares. And this 25 I took to the right. Now you can see we have kind of approached our result. 25 is 5 squared, so I'll bring it to the left. So we'll write this as 6a minus 12b whole square divided by, instead of 25, I'm writing 5 square here, and we have ab. Correct? So that is as good as writing 6a minus 12b over 5 whole square equals to ab. Correct? Now since we have these square root terms, I'll now take the square root. So we could write this as 6a minus 12b over 5 equals to square root of a or square root of ab. Now let's take log, since we need to get the result which is shown right there. So from here we need to take log to complete the answer. So if I take log both sides, I get log of 6a minus 12b divided by 5 equals to log of square root of a times square root of b. So that could be written as log of 6a minus 12b over 5 equals to log of square root of a plus log of square root of b. Right? So in this particular situation, we should have given the condition also that a is greater than 0 and b is also greater than 0. Correct? So that is how you actually prove it. So that brings us to the end of the video. I hope you enjoyed the way it has been solved. These 4 questions are extremely important from test point of view. Take your time to go through them once again. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.